Hey, Kevin, how you doing? We're here and we're ready for some questions. Ooh, I need my coffee this morning. I need all the coffee. But how you doing, Kevin? A little chill music right here. If anyone has any questions, starting up the office hours. People are messaging on Discord, getting a lot of good questions in. Let's do almost done with homework 1. Nice job. What are you working on? What part of homework 1 are you working on currently? What part of homework 1 are you working on? I think 474, right? I've got homework 1 up over here. 8B. Let's go look at some 8B. Okay. Oh, you are almost done, aren't you? Okay, good deal. Yes, 474. Nice job, Kevin. Excellent work. Let's put a time. So I sent you my code in Discord. I think it's right. Let's take a look. Oh, wait. Oh, there you are. I see it. Okay, define price to be the bug. Get rid of the same problems, guess, and the missing vector. Replace all the price fixed that are greater than 100 with NAs. Nice job. Yeah, looks like you did that. You found within it. Yes. Replace all the NAs with the median. I think you did it. Yeah, we could talk about some 8B right here, but Kevin, you're rocking and rolling right there, man. Great job. Is it getting easier the more you do it? Like, it's like, okay, it's like pushing some dust off of it and being like, I got this. Starting to make sense again. Starting to get my coding wheels turning. BS474, we'll look at 8B. So I think you've done it. If you want to do like 8C, we could do that. Homework 1. 8B. Let's go check out some 8B. Here we go. Haven't touched R&D here. You got this. You're doing great. Okay, so 8C would be great. Here, let's do 8C instead. Well, let's do it. Okay, so 8C says there are column constraints in this data set. Okay, so column constraint means there's values that just wouldn't make sense. The value in low should be less than or equal to the value in high. So these are things what I think notebooks were selling for, prices of notebooks from Amazon sales from, I can't remember the data set we got it from, but it's price of notebook sales I believe we're working with here. So low should be less than or equal to high. So we need to do that with a logical check. The value in price should be at least low and at most high, so it has to be contained within that interval. And when the stock is either in low, when stock is either in or low, the values of sellers should not equal 0. Yeah. So think about this. Just think about it logically right here. If we say something is in stock, there has to be whatters. So finish my sentence. Or there has to be people whatting the item. If we say the volume is the thing is in stock, so if something is in stock, like if stock is in or stock is low, then the people who are blanking this should not be 0. Like, just think about it theoretically right here, what we mean by this. Like, don't think of this as like, it's like, oh, if it's in stock, then there should be people whatting it. Like, if you're going to go buy a notebook, if it's in stock, then it should be what somewhere. Does that make sense, Kevin, what I'm asking? Like, this last constraint right here says, if it's in, like, stock or it's on low stock, then there should be people whatting it, meaning it can't be equal to 0. So there should be people whatting the item then. Like, we should see at least one option. There should be a count, or the amount of people blanking the item should be greater than 0. We can buy it, which means there's people selling it, right? So the people selling it, there can't be no one selling it. If we're saying it's in stock, we can't say there's 0 people selling it. That wouldn't make sense, right? If I say, oh, it's in stock, you say, where can I buy it? You say, you can't buy it anywhere. You say, well, then how is it in stock? How can I buy an item that is not being sold anywhere? So that's what this constraint goes over. And the other ones go over logical things with price, that if we say what's the lowest price of a notebook, the lowest price has to be lower than the high price. So those have to be like lowest to be lower than high. And then the price of the notebook has to be contained within low and high. Like, what is the current selling price? Well, it can't be lower than what it's ever sold for, because then that'd be the low. And it can't be higher than whatever it's sold for. So whatever current price is has to be contained in the interval. And that's what that one's getting at right there. So it looks like there is going to be some issues with that one. Use the mean of logical to determine what fraction of rows violate each constraint. Do this for each bullet point separate. So what you're doing right here is you're doing 3 different constraints, 3 different logical checks to look at the validity of data to see if it actually is working. So I'm going to work with a different data set here and talk about how to like build a logical set of conditions right here. And so when we think about this, we have something like, I think one of these data sets, similar but different work. And if you're here right now, if you tuned into this video, you can ask any question. We're just working on this till another question comes up and showing how to do this. but please drop a question in that you're working on. This is your time. Hey, Julia, so good to see you. Good morning. When I type short write-ups would suffice for data analytics 2. Yeah, Julia, we can cover that next right here. Let me put it in the notes. Data analytics 2. I have the YouTube video going over it. Data analytics 2 for Stat 201. We'll be doing that here in just about 10 minutes probably. So if you want to hang out, I've got it here in the notes. Julia, let's write another 100 points. Thank you for being here and asking about that. We'll do that here next. You got it. And we'll talk about those write-ups and we'll go over like some example data. You got it, Julia. Thank you so much for swinging by. So we're going to work actually with some Stats 1 data here. Yeah, awesome stuff. So this is very old school Stats 1 data here, Survey 09 from Reg class. And I think this one has a little bit of issues. Let me look to see if it's one of the data sets I wanted. We'll clear out everything over there. And let me see if this is the data set I'm thinking of. I think it's got it. Yeah. Okay. So we asked people questions like, how many drinks would you have at a party? So let's say you're going out and you're going to go to a party. What is a reasonable amount that someone might say if they're going to say how many drinks? We're talking alcoholic drinks they might have at a party. So if you're over 21, you remember that data set? Yeah. So if we go to survey and we said drinks at a party right here, how many drinks? What do you think is a reasonable amount? I think the craziest of people, I don't think people are really going to top 20. Like 20 is where it gets a little bit like, I'm just saying, like, that's where you're going to, like, serious harm is going to come to yourself. Like, I don't think a reasonable person would ever say more than 20. Like, and that's a ridiculous upper cap. Yeah, so that's exactly what I'm getting at. And if you look at some of the numbers right here, we do have some 20s, but that's not even the craziest. Is we go to max, and max is NA, so we got to do NA.remove equals true, and the max is 100. So even if you think 20, someone could have 20 drinks. Andre the Giant throwing back 20 beers. I don't think he's going to throw back 100. So 100, I think, is completely ridiculous. I'm setting my boundary on 20. We could also do the following and look at that individual with which max, which is another thing we cover in this assignment. They're individual number 5. So let's just go to Survey 09, row 5, and take a look. They've seen 1,000 movies in the theater. They work 168 hours a week. They've missed 150 classes. Do you think this person took our survey serious? They sleep 24 hours a night. They pay 2% of their tuition or something. They've been to 14 football games in the season, so they'll go to every football game. I don't think they took our survey seriously. So they need to be tossed out. So this would be an integrity issue alone. So let's go back here and write our constraint. So we just did some data investigation right there. Great job, Kevin. This is what we want to do, and I'm going to make sure in about 7 minutes. Now, you know what? I'm going to put on a 5-minute timer, and we're going to go on to the next question here after 5 minutes. So stay tuned, Julia. 5-minute timer's on. So we're going to say less than 20. So these people right here are people we want to keep in our data set. These are people who are, and we have NAs right there. So, thank you. So we'll not worry about those NAs right there. We'll just go for, let's say not less than. Here, let's do this. How many people break this constraint? There you go. There's the ones that break this constraint. So those are the people who break this constraint right here. We could find out the sum of them. We got to do NA remove equals true on it. NA remove equals true. So there's 6 people in the data set. So we could do 6 divided by 579. 6 divided by 579 is going to give us that. I'm trying to remember. Yes, because the NAs don't count. So what I might do instead, because the NAs don't count, that's the issue why we're getting right there. Because there were people who didn't report how much they drank. I'd probably go by length of the data set. So in this instance, because I want to say, well, if people didn't report, I'm going to assume they don't drink. So I'm going to say that they're valid. We just don't have a data thing for them. So those are people who don't meet that constraint. Now, another constraint is people said, I think this had age of first marry. Age of first kiss. People talk about like getting like kissed on the playground, like, oh, this is kindergarten, kissed on the playground. So let's say, I don't know, I'm gonna do whatever. Parents graduate college. There's a lot of validation issues with this data set. Gender, weight. Okay, let's do weight. In adults, and remember, adults come in many sizes and shapes. An adult should probably not weigh less than what? Now, do remember, not every adult is 5 feet tall, and every adult is 4 feet tall. But an adult, give me an adult should probably not weigh less than. No, there's definitely adults who weigh less than 100 pounds. Definitely. Don't worry, Kevin. 100 points are there. There's definitely adults who weigh less than 100 pounds. Like one of my friends, I've got friends that weigh less than 100 pounds. Like, definitely 75. I'd even go lower than that. I'd even go lower. I'm going to put a lower limit on adult weight of 30 pounds. That's a bit ridiculous. So, but I think everyone would agree that I don't think there's any adults who weigh less than 30. 50 maybe, but even then, remember, there are people who are 3-4 feet tall. So adults come in many shapes and sizes. There's 3 feet tall people. There's 8 feet tall. Well, close to 8 feet tall. 7 feet. I think the tallest person's been taller than 8 feet. So very, very extreme values, right? But check this out. If we say weight is less than 30, do we see... Oh, we don't today. Well, that validated. Here, let's go with 50. Well, we can do it quicker by doing some. One person. There they are right there. Oh, it's that person number 5 again. Person number 5. Messing with our survey. Person number 5 saying that they weigh 16 pounds. So we could have done weight less than 30. And we would have still found person number 5 saying they weigh 16 pounds. Now, they're double counted here. They're one big integrity issue, so we'll lump them together. Then we could also have, how much do you sleep at night? Let's look at that one. Or we could say you shouldn't weigh more than what? Hey, Corbin, good to see you here. Probably, I don't think, not that you shouldn't. Evan, good to see you here too. Not that you shouldn't weigh more than this, but I don't think anyone in college weighs more than... Let's say 800 pounds. That's a bit ridiculous. Like, I mean, just not to weigh 800 pounds, but that high of a value. Like, I don't think anyone is going to weigh more than 800. And we don't see anybody. You have to think to the extremes that wouldn't exist. And there is nobody. So we've set some boundaries right here. So what we want to do now is we want to join together the logical conditions. We want to join them together. 100 points for everyone being here. We want to take this one right here. That somebody does not drink less than 20 drinks. Does that make sense? Someone does not drink less than 20 drinks. And then we also want... So those are the people who don't drink less than 20 drinks. And we want and the person... Or no, or. We want or. Because it's going to do if there's one true. Or the person... weighs less than 30 pounds, or the person weighs more than 100. There we go, right there. And we do get some NAs. I probably need to do the following really quickly to this to make it work. And then we're going to switch topics. Is.NA. Tell me what I'm doing right here with this. Can anybody tell me positions? Interpret this code. Then we're about to do the next question. Good to see you right here. Get into that Brian tier right there. Tell me, Kevin, can you understand what I'm doing right here? What have I done to this question? What have I done to this data set right here? Interpret that code. What does that code do right there? And then we're about to switch to analytics 2. What does this code do right here? Because replaces the NAs with zeros. Exactly. Great job, Kevin, understanding the code. I was trying to zoom in on a little bit and it went away from it. I found the positions of the NAs. So I said, are these things NA? And then I stored it as positions. Then I went to the vector itself and went to those positions and I overwrote them with 0. Because I'm assuming if somebody didn't give an answer to this question, I'm assuming that they just wanted to say that they don't drink. Like if someone says, if we say, how many drinks do you drink at a party? And they say, that doesn't apply to me. Well, then they don't drink drinks at parties, which is totally cool. But I mean, like then the answer is 0. So now when I run this right here, it'll actually do the logical check. And I could do this, store this into an object called logical. And we could just go right here and take the mean of the logical vector and find out that 10%, around 1%, excuse me, around 1% of our data has issues. We could do a sum. I think it's going to be 6 or 7. It's 6. So six rows in this data set have issues. And that's how we're kind of checking out like these different conditions. Do they say that they drink less? Do they not drink 20 less drinks at a party? So that's not drinking less than 20 drinks. weight is less than 30. So ors, because it's like, do they not drink less than 20 drinks, or is their weight less than 30, or is their weight greater than 800? If they meet any of those conditions, they're going to come back as an issue right here because we don't think those are valid answers. So that would be an integrity issue with one of the rows in the data set. So think about how this applies to your question to write each of these constraints right here where you're checking the value of low that is less than high, or high is less than low, things like that, and to check each of these to find the percentages. Okay, time for some data analytics too. Let's do this. Thank you so much, everybody. Good to see everyone here. Now, please drop those questions in the chat because we're just working away on them. 1810, data analytics 2. Okay. My hair is getting so long. Data analytics 2, visualization, getting it ready to go right here. Have it up on the screen in just a moment. Okay, let's go and take a look at it. Here we go. Okay, it's Data Analytics 2. Hey, Brian, I can't make today. I'm a part of a veteran green zone panel. Oh, cool stuff. Kimberly, if you want to post about that, post about it. That's cool, Kimberly. Yeah, thank you for your service. It sounds like you are a veteran. Thank you for your service. And that sounds like a really cool panel. If you want to post links anywhere, let us know. Number 9, we could check some number 9 here next, Morgan. Let me take a note on that. I'm going to re-timestamp this for people watching in the future. And let me put right here, question number 9 coming up next. You got it, Morgan. Good questions right there. Well, that's all right. That happens. Recorded. That's why we record class. And have a great time. You're always welcome to check out the recording. Use the diamond data sets. Take a random sample of 700 plus the last 2 of your UTID. So you'll want to do 700 something. And then right here, create a bar chart, a pie chart, and a histogram. You're welcome anytime. 100 points. Just thank you for swinging by. I appreciate that. So bar chart, pie chart, histogram. Let's download some data. Let's see if Jump opens today. It's been telling me you need to update your license. And I update. Oh, still saying update the license. And then I go here and I go get that Jump license. I click it and it says, okay. And this your license has been accepted. And it says, I'll open your data for you. Could you go more in depth on the write-ups? You bet. Let's do that. So here we are. We got the data set open. And so this is the diamond data set. I was able to follow a video about making the charts. Nice job. So if you haven't heard it, or if you didn't know, we have the visualization videos. I'm dropping the link in the chat right there. MuBot's going to post it. The visualization helps. That's what Julia is pointing to right here. I'm going to open in new tab. And you can see right here the visualization tab, which I just put in the chat right there. I think Julia used the visualizing bar charts and histograms with slightly longer hair, Brian, right there. And so we're going to be making these graphics in just a second here, and let's show how to do them. Okay, so let's make one of these graphics. Let's make a histogram, and I'm going to choose one of these. And which one? Is there a specific one you wanted to go over, Julia? Like histogram, bar chart, pie chart? So the question or the assignment has us do all 3. And so look at what we have to analyze and always look at the rubric to see how the rubric says you'll be graded. So always be like, am I doing it? Look at the histogram right here. Histogram of a particular variable with the display options added to the graphic. Include a short write-up using the information from the graphic. Visualization was created and includes the short write-up, the accurate write-up. So let's look at the histogram right here. Histogram of price. Brian is doing a different variable. So can someone type that in the chat for 100 points? Brian is doing a different variable. I'm going to keep saying it while I'm doing this. Someone's probably watching this in the background. Brian is doing a different variable. Brian is doing a different variable. Oh, this is what we're about to do, Julia, right here. I'm about to talk through it. Brian is doing a different variable. I am doing carat. So I'm not doing the same variable. I am doing a different variable. You're doing price. I'm doing carat. So I'm doing a different variable. So I'm doing carat right here. And we're going to stack it. This is in the video, but I'm going to stack it like I do in the video. And then I'm going to go right here. I'm going to make it a little bit bigger. There we go. Make it a little bit bigger. I'm going to go to the down arrow, go to histogram options, count axis. I'll pause right here. This is a very important one to add the count axis. Brian's doing a different variable. You bet I am. Thank you, Evan, right there. And then I'm going to go here to histogram options, and I'm going to go to color because I want to. I'm going to make it a nice purple right there. There we go. Nice purple histogram. Okay, you can make it whatever color you like. All good by me. Now, when we interpret histograms, there's 3 things we need to talk about. I'll give you a hint. You ready? Shape, center, and what's the third? So write these down if you're studying right now to practice and understand there's 3 things to talk about when talking about a histogram. Shape, center. Evan, you're on the right track, 100 points. Shape, center, spread. Shape, center, spread. So you basically want to try to write a full sentence on each one of those for this. You ready? So shape deals with modality. It deals with skew or symmetric and outliers and gaps. So shape has within it, and let's probably write these down. So shape has within it. So interpreting histogram, we have shape, center, spread. Okay. So shape has in it modality. It has skew versus symmetric. And it has outliers / gaps. So how does this apply to our graphic here? Let's take a screenshot of it and bring it over to this graphic. Okay. Talk to me about the shape of our graphic right here. Talk to me about the shape of it. Just look at it and be like, so I don't know. You got to watch out with those bins because I'm going to do something here. Talk to me about the shape of it. Ooh, maybe. Maybe. I see it, right? It's definitely right skew. 100% right skew. Definitely right skew. Yeah, when I do this right here, Julia, so you have to, the bins control how much data is in each thing. So I'm like, is it bimodal? And then I saw, because that looks unimodal. This is the same data. It's just how wide are you making the bins which collect the data? Like I could collect the data all into one bin. It'd just be one big bump right there. Jay, good to see you here. Then we could make it little tiny bins. It's all the same data. The numbers aren't changing. It's just the way it's being visually displayed. But there does look to be a bimodality to it. And look at where, this is diamonds, right? And this is the number of carats. So someone's either getting you a woo, or someone's getting you a hey. So what do you think's going on here? Interpret what you know about the world. Like someone's either getting you a or someone's getting you a, or then there's the, actually maybe there's some, if you notice where the modalities are at, you notice where it's kind of got, might be even multimodal here. What do you notice about this? Like, just talk to me about what you know about diamonds. Or look where they're at. Kind of around some interesting numbers for carats. Someone walks up and they're like, "Oh, look at my this." We always want to think about what the data means and what it's telling us. So we could write a lot about this one. So when people are buying diamonds, there's definitely a second peak around where? Where's that second peak around? Where's that second peak very close to? Because these are diamonds, 1 carat diamonds, right? It's like, oh, I got a 1 carat diamond. So so Evan, tell your significant other that you're getting them a 0.1 carat diamond and see what they say. They might say, hey, thank you so much. I'd like any gift from you. And you say, you are the best significant other ever. Or they might say, wait, this is the engagement ring 0.1. What are you doing? It all depends. It all depends. I say, if you're happy with it, you're happy with it. I'm guessing that would be a mistake. Yeah, it just depends on whatever your relationship is and whatever the person you like or dislike. So if my wife told me she got me a 2 carat diamond ring, I'd say why. And if I told her I got her a 2 carat diamond ring, she'd probably say why. It's our relationship. So it all depends. Depends on what you want. It's all what you want. But what do a lot of people want? Well, a lot of people seem to want 1 carat diamonds, and a lot of people seem to want maybe around this 0.5. Now, there's a lower modal area around here, but I would say this is like multimodal. Then there's some mode around 1.5, mode around 2. So this is probably multimodal or bimodal. There's some bimodality, maybe little smaller other modes around the higher diamond carats. It's just that those are going to be really, really expensive. And then Julia pointed out this is right skewed. So we need to say things like, if I'm writing this down, Julia, I'd write down like, there is some strong bimodality here around 0.5 and also 1. There might even be smaller modes at the higher carats of diamonds, but they're not as apparent. The data is very right skewed with extreme right outliers, with the very high diamonds at the like 2.5 carat. These are extremely high values that are not like the other diamonds right there. So we just interpreted the what. Just tell me one word. I'll say this again. You just say the one word in the chat. I am interpreting the what right now. This data on carats is extremely right skewed with multimodal but prevalent yes data. But what I'm interpreting the what of the data. So it is very right skewed with strong bimodality of it. So what am I saying about the data right now? I'm pointing to it right there. So it has strong bimodality around the 0.5. Great job, Evan, right there. Around the 0.5 and around the 1 carat areas. There might be smaller modes later on, but the bimodality is most present. We see right skew of the histogram, and there are outliers at the far end. Not as big of gaps, but the 2.5 has a little bit of a gap between it and the next diamond right there. A little bit of a gap, but there are extreme outliers. So we just interpreted the shape. Now, shape is so important because, and this is what we're going to start today's lecture with, center and spread depend on the shape. So if skewed, the center is median. If normal, we'll draw what a normal looks like. If normal, then it is the mean. Now, only supply the one that matters. I think the assignment says that, like, only supply the one you're talking about, like the one that will best describe it. So here, if normal, then it's going to be the standard deviation. There we go. If skewed, it's going to be the IQR, which is the interquartile range. So what should we talk about for the center? What should we talk about for the spread? What should we talk about for the center? So remember my interpretation. The proper measure of center is going to be this. The proper measure of spread is going to be this. For my data up there, the proper measure, and these are the notes, don't write what I'm writing, but the proper measure of center is going to be the median. So we probably want to say, like, the proper measure of center is the median, which represents the 50th percentile of carats and is a diamond with 0.71 carats. Does that make sense? So the proper measure, this is what I'd be writing. The proper measure of center is the median because of the right skew. This tells us that the 50th percentile of carats is 0.71. Now the IQR is the range of the middle 50%. So the IQR stands for the interquartile range, interquarters. Interquarters would be 2 quarters. 2 quarters is 50% of the data. So this is the interquartile range of the data set. And I didn't take a random sample. Please make sure to take your random sample. I didn't do that for this example. So 1.06 minus 0.41, and the interquartile range is 0.65. So this tells us the spread of the middle 50% of carats is 0.65 carats. I'll repeat that again. The spread, which is the range of the middle 50% of carats, is 0.65. The range of the middle 50%, which represents the spread of the data, is 0.65 carats. Does that make sense, Julie, right there, how to interpret this? And when you're interpreting a histogram, we look at shape, center, spread, and shape determines the rest of the interpretation from there. So make sure to use full sentences. Make sure it's very clear if you're using the median for center or the mean for center. Make sure if it's clear that you're using the standard deviation for spread. But here's the thing, is if you are using the median, then what do you have to use for spread? If you say I'm using the median for center, what's your spread? So as soon as you're like, oh, the median's the best measure of center, then instantaneously, what's your best measure of spread? IQR. Great job, Julia, right there. Keep getting those points. And then if you're saying use the mean, then if you use the mean, you want to use standard deviation. And I said I'd show you what normal data looks like. Normal data is going to look like this right here, where skewed data is going to look like this, skewed or outlier data. Left or right skew, Rock knows. It doesn't matter. Rocky's so quiet. Yelling, it doesn't matter. Julie, do you have additional questions? Do you want to do one more of these? So this was interpreting histograms. Histograms. Should we do one more? Also for number one, what do you mean by levels? Oh, good question right there. Let's talk about levels right here. So let's put another timestamp in the video, 31:45. So this is bar charts, right? Bars and pies, basically. Okay, let's talk about those levels. So when we're talking about a thing with levels, and I think we didn't do color. So I'm going to do color. Once again, remember, Brian's doing he's doing the data set, but he's not doing the same variables. You do want to take a random sample. You will lose points if you are doing this and use the 1000, you will lose points. So technically you want to go to table subset, table subset. And in table subset, you want to take, I think it was 700 plus the last two of your UTID, and then go ahead and click enter, and you're good. You now have your subset. Make sure your graphics are made with a subset. Sometimes I don't do it because I'm just showing how to do it, like how to do a bar chart, pie chart, histogram. But if the instructions say take a subset, make sure to take a subset to make sure you're using your own data set. You will get slightly different answers than me because you have a random subset. So now we're going to go right here and make a, do you want to do bar or pie? Bar or pie? Because they both deal with levels. Levels is an answer to a question. That's what a level is. Let's go bar chart. One of my favorite ways to make a bar chart is go to analyze distribution. Couldn't we do both? Yeah, let's do both. Bars and pies. Why not? Why can't it be both? Good question, Evan. So a bar chart and a pie chart display the same type of data. Important to see that a bar chart and a pie chart, if you notice up there, can be used interchangeably. You can make a pie chart your favorite bars and a bar chart your favorite pies. They're interchangeable in what they display. And there's other graphics like a Pareto chart, which is a bar chart in order, frequency table, and no one likes ring charts that all display univariate categorical data. If you don't have a picture of this, it's a great graphic visualization of the different types of graphics you need to understand. And so take a picture if you don't have it. It's a good way to remember what you need to know. So let's go ahead and make a bar chart. I like to do it via analyze distribution. Analyze distribution. Now we go in here and I'm going to select, I think, the variable you're not using, which is color. I don't think we're using color for any of these. How do we know which box to use if we're solely using quantitative, for instance? If you're solely using quantitative, that's the one up here. You see how there's nothing on the X variable? See, so this is the combination of variables, but there's nothing over there on the X. Like if you look this way, it's just a quantitative Y variable, meaning the variable you want to understand. So one quantitative Y variable is up here, one quantitative X variable, and these are the bivariate combinations in here. Like this box I'm pointing to right now is quantitative, 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 quantitative. If you like zero in on it, if you look down the up, down, this is the quantitative column, and this is the quantitative row. So these are bivariate quantitative. This is a bivariate quantitative Y, categorical X, and then the one I'm covering up right here in the bottom right is categorical with mosaic plots, which I think we'll be covering today. So good question right there, Evan, about using this to understand which graphics you're doing. Now, it does call this a histogram, which drives me absolutely crazy. This is a bar chart because it's categorical. I think Jump says it's a histogram. If you go to options and it says histogram options, they really need to update that. But we're going to go right here to count axis. It is a bar chart because it's categorical. Histograms have a quantitative axis. Bar charts have categories down here. So we're going to go to count axis, and we now have the count axis, and we can see what's going on. So how would we interpret this? This is the color of a diamond. The most common color of a diamond is what? The most common, and so we can look at the levels. Here's level I. Here's level F. Here's level E. The most common color of a diamond is G. So we could say to somebody, there were 160 diamonds with color G. And we just kind of need to talk through this, talk about the most and least common. You're probably safest if you just mention all the levels. Does that make more sense, Julia, what a level is? A level is an answer to a question. So if I say, oh, what color is your diamond? You say I. You've reported a level to me. And there were 70 people, or 9.83% of people who reported that. So you actually get the frequency and the relative frequency. So then we're reviewing terms right here like frequency or relative. So you could throw that in your thing to like help you remember. The relative frequency of this level was 9% or 9.8 of the level I. You could say people who reported I, but that just means level. So level would be the letters at the bottom, and the frequency would be the yes. Great job. Should we talk about all the levels? You could. They shouldn't count off for saying too much. You can only really get counted off for saying too little. I mean, if you write 20 pages, there's not 20 pages of stuff to say on this. But I always tell students to do a little extra just in case, because rarely, and if you think you get counted off for saying too much, just let me know. Like I'm not against people saying a little extra, but if you say, you probably are fine to not say everything, but I would say everything. Graders have variation. And I always think you can argue if you say more. But so yeah, I would say a little bit. I'd say is like, just write a few sentences. Like, I'll get this knocked out. Write a few sentences right here. Now we're gonna see the same terminology, and this is how to make the pie chart. To make a pie chart here, we're gonna go to graph. We're gonna unselect stuff real quick. We're gonna go to graph builder. Graph Graph Builder. Graph Builder. Under Graph Builder, we're going to take and drop, and we were doing color, right? So we're going to take and drop color right into here. It's not a pie chart yet. And we're just going to click the pie button right here. With the pie button clicked, we are now going to click to labels, and then we're going to click to percent by total row. I think you can use either one of these. Make sure to check. It might say to use the value or the percent. Either one's fine in my opinion, but this is giving the values right there. If it does it say put the values over the bars? Ooh, let me see on your bar chart. Take a screenshot. Include the values above the bars. Okay, wait. Julia, I forgot something. I knew it said that. My brain was saying, Brian, stop. When you do this right here, if you're watching this right now, make sure to put the values above the bars. You're gonna do that apparently. I didn't do one thing. Okay, so I put a count axis, and so we're going right here to the red arrow, histogram, count axis. There we go. And then you have to go right here to the red arrow, histogram options, and then show counts. So please, everyone, make sure to do this. Histogram options, show counts, and the question wants you to do that. I don't always do it, but it's a little clearer to see now if you take a look at it. But does that make sense, Julia? Are you good on that? Do you have the counts above the bars? If you're in night mode on a Mac, and I have this in the visualization playlist, I think night mode doesn't show up on some versions of Jump, like it doesn't show the numbers. So you actually have to switch off night mode, which is a bit crazy, but let me know if there's problems. But make sure to have these numbers above the bars. I don't want anyone to lose points if they're following along. Both of your graphics should look like this and like this, not the same thing. But you see right here, we have the proper bar chart and we have the proper pie chart. Now I'm using the same what for this. And I could even change this to pie chart of color. You can edit your titles. So color of diamond. So I have the same variable. This is still just the color of the diamond with the percentages. And does this one ask to do percentages, label by value, or label by percent? So it says either one right there. So right here, you can even change distribution to say pie chart or bar chart. Bar chart of color and color of diamonds. You can edit those stuff right there. Wouldn't we talk about the skew? So this is not quantitative data. Good questions there, Julia. This is not quantitative data, so it's not skewed. Because technically the bars really have no order to them. So we wouldn't talk about skew right here. Skew only applies to what kind of data? If you're talking about skew would only apply to histograms, and histograms are for what kind of data? Skew only applies to histograms, and histograms are for what kind of data? Histograms and histograms are what kind of data? So it wouldn't apply quantitative, right? So in this instance, we talk about like the most and least common groups. There's no real skew to it because you might say, well, the bars follow like, they might be modal or something, but you can mix up bars. Imagine if I had like the animals people own, and that would be displayed in a bar chart. And if we looked at the data this way, and we had bunny, so bun, cat, dog, you might say, okay, Brian, that is left skew because the Monster Man's tail goes to the left. But the thing is there's no reason for it to have this order. It could have been put in order dog, cat, and then bunny, which is the right choice to the answer. What animal do you own? Now, if I put it in order, it looks right skew. But let me ask you this. By putting bars in order, I've actually made a what chart? Good review question right here. If I put bars in order, I've actually made a what chart? By putting the bars in order, I've actually made a what chart? And there's a hint on the screen right now. It is a bar chart still, but it's a special kind of bar chart. Look at the top right. The review question right here. By putting the bars in order, I've made a special bar chart known as a what? A Pareto. Great job right there. So that's a Pareto. So you can actually do these inside of Jump. Great job, Evan, right there. If we go back to our Jump data, we could go to Analyze. This one's hidden away in Quality Process under Pareto right there. There it is, Pareto. So we can add in the color of a diamond for Pareto. And if you look, we get the Pareto chart right here, and we can move the axis to make it look more like a bar chart. So there, I could probably take away the cumulative axis. But there is a Pareto plot right here. It doesn't have the numbers over the bars, so if we turn this in, oh, we can move the cumulative axis. There we go. And then that's a bummer. I don't know how to add the numbers of the bars. Background color. Light purple. There we go. Looks like a sunset. So actually looks like an old video game I used to play. So there's a Pareto. I can't get the numbers over the bars as far as I can tell. Quazzes. Yeah, markers. I'm just going to click every button. But this is a Pareto right here. It's been put in order. How are we doing, everybody? Does it make sense that we have pie charts, we have bar charts, and we have Paretos, which have been put in order? We would talk about the most common and least common levels here, the percentages by which they occur. So we can say things like the most common color was color G, which occurred this percent of the time. We could talk about the counts, make sure to have these values. And great job right there, Julia and Evan. Excellent job practicing and remembering these topics, analyzing univariate quantitative or univariate categorical data. Let's head back right here to the main screen. Let's do it. Thank you for swinging by, everyone here. I think that's going to really help out people in the classes because it's all about just review and practice. That's what we're here to do. I think we have question number 9, so you can get to see some advanced analytics. Okay, we got some transformations of data. Let's go look at question number 9 right here. We'll take the timestamp. Bars, pies, and bars. Pies and bars. Okay, question number 9. And drop those questions. Hey, Professor, you do number 3 on Chapter 2 homework after Stats 202? Oh my gosh. What is Stats 202? Stats 202. Yeah, we can do that, Evan. You got it. I'm just messing around. Stats 201. So number 3 on Chapter 2. Chapter 3 homework number 2. Chapter 3 or homework. Okay, chapter 3, homework 2, question. Wait, homework 3, right? Homework 3, question. Oh my gosh, my brain's breaking. Could you do? Wait, so it's chapter 2 homework. What's the question say? Chapter 2 homework number 3. Okay, there we go. There. Thank you. There we go. Awesome. Okay, let me timestamp this here. Thank you, Evan, right there. My brain was breaking. I think you gave like the My Pearson number, which it shows on the side of the screen, and then my brain just couldn't comprehend it. It happens sometimes. Our brain just like reboots while we're doing things. Hey kid, I'm a computer. Life expectancy, you bet. In business analytics, very often we do transformations of data. So transformations are just like log transformations. You just move data around, you make it new values that work better with the algorithms that we use. So imagine that a model is made predicting the log 10 of the closing price of stocks. My hair is just going crazy. The number output from the model are 0, 0.032, 1.7, 3.66, 4.2. Untransform this data. Okay, so these data have been log 10. Similar but different work. Okay, I always do similar but different work right here. A model has taken the natural log of the following, turn them back to their original values. So the natural log means if we had data that was, let's say, 8, 4, 2, and let's go to 1, then if we natural log it, so we'd be going log, and this is log base E, which is the natural log, we'd be doing log of X. So if you look over here at the side of it, or we could do something like exp1, there we go, that's better. Because now E is written as exp1, so if we do log base E of E, it's going to be 1, which is the third thing right here. Now 1 is what do we raise E to get 1? And if you raise E to 0, then you get 1. So that's why this becomes 0. So the answer of what do you raise E to get 1 is going to be 0. That's the log base E. And this is base E. If you don't add in a base, it's going to be base E by default. And you can see we get the same answers right here. Also, looking at the log function does confirm this, that it uses log base E if we don't enter in anything. So you want to take a look right here and see it's using log base e by default. And there are other ways to do log, like log 10 right there. So the question becomes, if we have that we've done this to our data, so here's the transformed values. Now we want to untransform these values, which is what the question is getting at. We have these values that are transformed. Now we want to untransform them. We want to unlog base e them. So we would take right here, and the way to untransform something that's been logged is to take the base of the log, which was base e, and raise it to the values. And you'll notice right here, watch, we get 8, 4, 2.7, 1828, and then 1. So we get the original values, and this is the transformation done by the model, transformed, and this is the untransformed. Imagine that a model is made predicting a transformation of checking accounts. In the raw data, the minimum checking account was this. The model predicts the log 10 of the balance after this has been added. So you have to look at what was done to the data, is that we have some original data right here. That would be values like X, and once again, similar but different work. And we're getting values something like negative 39, did I do 39? 40, 80, negative 2. So the problem is you might say, why don't you just log base e this? Remember, I am doing similar but different work. So log base e of this, if we take of X, we don't get values right there because you can't log negative numbers. So to fix this problem, we're going to take right here and add to it 40. Add 40? Yeah. Now, if you take a look at it, we're adding 40 and then we're log base e-ing it. And since this becomes 1, the minimum value becomes 1, now when we log base e it, we get 0. We get 0. So this is similar but different work where we've logged base e something. And look at how yours is different than mine. The model predicts, and you're doing different loggings, you're doing different addings. But if we take the log base e of something, it's still logging it. And we're adding 40 to set them equal to 1. So if you look at the process, you would take X, add 40. That makes all the numbers positive right here. And the lowest number is now 1. So if you do the same process we did before by taking the log of this, you will get 0 for the lowest value. Yeah, hey, Morgan, great job. That's what I'm hoping. I was hoping someone doesn't see this and like, what the heck is he doing? I'm just showing how the transformations work. And then if we had this as our answer right here, like if this is the transformed values, which the model is doing, transformed values, we then have to think about how to untransform it. So the first thing I'm going to do to it is I'm going to, oh my gosh, I'm going to take E is the value, so exp1, and then my brain's like, how to do this. And then there's the values, yeah, there we go. So I'm going to undo that, and then I'm going to subtract 40. And that confirms I've undone it. So you have to be very careful in how you do it. That's got it. We're going to take a 2-minute break and be right back here. So one moment, everyone. Be right back. Heyo, Evan. Let's see right here. Let's get that question up and going. Let's go grab it. Last question of the office hours. Gonna get some homework number 2 done. It says life expectancy. Try to remember that one. Heyo. What's that from? I like that. Got fantasy football coming up this week. Anyone else play some fantasy football? Are you ready for some football? Gonna have some Thursday night football. Was it the Bills versus the Rams? Rams were good, right? So if Bills win, is this the homework? Whoa. Homework's got a lot of questions. How's this start as life expectancy? You said it's chapter... Is it chapter 3? No, I don't think I've done it yet. You said homework 2, number 3. Number 3. I was doing number 2. All right, here we go. We can do a few of these. Okay, so let's check it out. Here we go. Let's do it. Yeah, we haven't done much of the homework yet, so we probably... Tomorrow might be a big day for homeworks. Or later today. So time stamped right here. This is the chapter 2, homework number 3. The accompanying histogram shows the life expectancy at birth for 190 countries. So this is quantitative. It's the life expectancy by an international health agency. Describe the shape of it. Boom. Now, when we look at the shape right here, we want to remember our monster man. That's a right-skewed monster man. What do I mean by this? Well, this one here is right-skewed because you look at the monster man. You see right to the high, left to the low, whatever way the tail goes. His tail goes to the high side of the data, right to the high. That is a right-skewed monster man. Right to the high, left to the low. So what way is this data skewed right here? What way is this data skewed right here? Right to the high, left to the low, whatever way the tail goes. What way does that data look skewed? Oh, yep. It's left skewed, right? Because remember, right to the high, left to the low, and low is the low side of the data, the lower numbers. So right to the high, left to the low, whatever way the tail goes. So that should be left skewed. Don't fail me now, my Pearson. You better not. Yeah, that's what I'm saying. Choose the correct one below. Okay, let's see. I think it's asking about the modality right here. There appears to be one mode at that. There appears to be 2 modes. That doesn't have any modes. Now, mode means most common area. So there's definitely a mode right here. And that mode is in the, there's breaks of 2. So that's the 74 through 76. Because that's where this is right here. And that's where that is. So definitely should be, how do you know if there's 2 modes? We like to see 2 clear modes. Like that is really good. If there's a secondary mode, we usually want it to be bigger than something like this. Like this would be no. This would be definitely yes. So is this a secondary mode? It's iffy. It's iffy. Let's see if they even give us one that could be that answer. Okay, so do you see how they say there's 2 modes here? They're putting a second mode at 64 to 66. So no. 64 to 66 is going to be 64 to 66 is this bin right here. The only other 2 mode answer would say that there's a mode here, where in truth, if there's a secondary mode, it's going to be over here, like people who die in their 70s and people who die in their 80s. But I'd say there's really one clear mode. So 74 to 76 is exactly what we did in our visual investigation of it. So they're basically trying to give you a pretty obvious answer and then other answers that are not possibly going to be it because there's not a secondary mode down here because that's where they're saying the secondary mode is. If I were to give one, I'd put it over here. It can be subjective on we think there's a secondary mode. Great questions right there, Ethan. Keep those points coming in right there. So it should definitely be one mode right here. Yep, one mode. It's mostly unimodal. I do agree with that. Hey, so we did it. Do you want to do another one? We got time. Do you want to do another one, Ethan? Do you want to do another number whatever on this? You just tell me and we'll do it. We got time. We don't have class till 23 minutes. Which one do you want to do? Hey, Corbin, good to see you here. We got time. Just be like, hey, let's talk about this one. Ethan Rip. No, Evan. Oh, did I say Ethan? I said Ethan or Evan. I'm sorry, Evan. Evan right there. Sorry, Evan. 100 points, Evan. Just Brian can't read is the theme of this class. I've had 2 eye surgeries. My eyes are so bad. I'm gonna increase font size right there so I can read Ethan from Evan, Evan from Ethan. So my eyes are like 2 eye surgeries. Number 4, you bet. Let's do it. Oh yeah, let's put a timestamp in here. Number 4. And timestamp in this number 4. Would you expect distributions in parts A through D to be uniform, unimodal? Oh, cool. It's like a yeah. Is that number 4? About to do that one? So let's look over it. It's good stuff. Okay, let's check this out. Number 4. Here we go. Retimestamp them. There we go. So, which would you expect to be larger, the mean or the median? So I think, is this the one? It's 8 for you. It's 8. We'll do 8 next. Here, you got it. Oh, does it mix up the questions? So I should put life expectancy on here. So we'll do that. Oh, Corbin wants number 4. Here we go. Which would you expect to be larger, the median or the mean? Explain briefly. Okay. So this is still the same sort of data right here. So when data is skewed, the mean follows the skew. So this is what skewed data. Remind us again, this is what skewed data. And someone type it in chat. The mean follows the skew. This is what skewed data. It's left skewed. Great job right there, Corbin. So that means the mean will be to the what of the median. Like if we have the median right here, since it's left skew, which means we have a lower tail. Remember, check your monster man, whatever way his tail goes. The mean will be to the left of the median. So the mean does what? Remind us again. The mean does what? That says mean if you can't read my highlighted text up there. That says mean. The mean does what? The mean does what? The mean follows the what? Well, it's the average. You are correct right there, Evan, right there. The mean follows the what, though? So the mean always follows the what, though? Now, median is the proper measure of center. But if you're thinking, where's the mean versus the median? The mean will always follow the what? Like, here's your median, and then the mean will always follow the where. The mean will always follow the where. Like, let's say we had data that had no skew. It's going to follow the skew, right? It's going to follow the tail. So if we had data that was not skewed, if it looked like this, where would the median and the mean be? We'll do a line right here for median. And then we'll do a line for mean. Where would the mean be if there's no skew? Kind of, well, think about this. There's no skew, right? So the mean's not going to go anywhere. So if there's no skew, the mean and the median would be where? If there's no skew, the mean and the median would be where? So it's not going anywhere. Yeah, it'd be, boom, great answer. Yeah, you're right there. There's no skew. 100 points. Great job, Evan. That's it. So there's not going anywhere. So now let's do another example, which we have right here. If we have right skew data, then we have the median right here, and the mean's going to be where now? So think about this. This is not the answer. I probably need to do a different line. I mean, it's not going to be there. Don't worry about that. The mean is going to go where? To the right, exactly. Does that make sense? So the mean follows the skew. If there is no skew, the mean and median are on top of each other. Like if the data is not pulled in a direction, if it's more unimodal normal right there, they're on top of each other. But then when the data is skewed, the mean goes in that direction. So the mean follows the skew. Like high numbers will pull the mean in the large direction. So the skew indicates which way the mean goes. So since this is left skew, the median will be larger because the distribution is left skew. So just make sure you understand skew pulls the mean in that direction. So the mean is going to be smaller. A lot of ways to phrase it, so it can be a little confusing right there. Choose the correct one below. Okay, this is great because we were covering this earlier. When data is skewed, what should we use? We just said the data is skewed. We should use what and what. So this is the answer on the screen. If data is skewed, we should use what and what. If data is skewed, we should use what and what. This is a great question right here. If data is skewed, we should use what and what. IQR for spread, correct. And because we figure out if it's skewed and all this good stuff up here. And then we should use median and IQR. Yeah, median for center and IQR. So the median should be used. This is choose the correct answer. The median should be used because the data is skewed. Yeah, that's literally it. Okay, cool. And then is going to, oh, it didn't ask about spread. It could have said, what spread should we use? Let's do number 8, and then we're going to head off right here. Thank you so much for all these questions. Remember, you can join in anytime. We'll try to knock out as many questions as you can. This is great review right here. It's what we try to do. So thank you. And remember, just swing by later today if you didn't do this. Do we have access to those notes that you take? I don't post them. Yeah, try to write them down or message me on Discord when I take them and say, hey, Brian, can you send me those notes? Yeah, I just write these down and then try to, the best thing to do oftentimes is to write them down too, and to like take these shorthands. Yeah, Evan, thank you for asking. 100 points for asking, Evan. Yeah, best thing to do is write them down, because then you got a lot of practice like putting your own words. And then if you want, just message me on Discord and I can send them to you too. The number, let's see right here. The number of speeding tickets. Okay. The number of speeding tickets each student in a senior class of a college has ever had. This distribution would probably be, so how many speeding tickets do you think Brian's ever had? How many speeding tickets do you think Brian's ever had? This is a bad question to ask. 2. Actually, I think it's about right. I think it's about right, Evan. So a lot of people probably have around 1, 2, 3. I think I've had 2. So I'm 40 though. So hey, there you go. 1, 2, 3. But then there might be some extreme values. So if people have around 1, 2, 1, 2, 1, 2, and then there's like someone who has 10, the distribution is probably going to be what? So think about this. There's people who probably have like 1 or 2, and then there's like people with like 10, 20, 100. So the distribution is probably going to be what? Think about these shapes right here that I'm looking at. Skewed right. Because you're going to have a lot of people at the lower side of it with like very small amounts, like 0, 2, and then you're going to have like the people with like 10 over here that are extreme values. And there's not going to be many of them. There's going to be like a few. So distribution is probably unimodal. A lot of people with like 1 or 2, and skewed because, let's see. Most data values will be, nope. Most students will have, nope. Most data values will be 0 or 1 with a few larger values. Yes. Uniform would be, if ever, the same probability. Uniform means a flat distribution. So if we had answered uniform, it would be like there's as many people getting 0 tickets as 10. I don't think it's going to be uniform. It's more centered around like 0 or 1 and a few larger values. Whew, that was a tricky one. Players scores number of strikes in the U.S. golf tournament in a given year. So yeah, so this is a golf tournament right here. So in a golf tournament, if you look at like players in the PGA, there might be some extreme values, but it's probably going to be more normal, because they're probably going to get around like 70 or 72, and then there's going to be some spread for people who do a little better, people who do a little worse. So I'd probably say it's going to be unimodal, like centered around one sort of value, like 70-ish, like the average pro golfer. And then we'd have here more symmetric, because some people are going to do a little better, a little worse. Unimodal, yeah, it'll be like around 70 is your average golf player, and a little better, a little worse. So it would look something like, if we were to put numbers to this, which is always a great way to think about it, if 70, which is how many hole, like par, and then like 60 down here and 80, that might be too big of a spread. Has anyone ever shot 60? I don't know if anyone knows golf. Like, that's 10 under par, right? So I guess you could. It'd be an amazing golf game. I think like a good 5, 6, 7 under par is pretty awesome. 60, maybe the best golf game is like 58. I don't think I've ever golfed. Yeah, that's the problem, is some of these take a little background knowledge. We try not to do that on the test. No. Every golfer will score above the mean. That's impossible. The mean's the mean. Every golfer will have a different score. No. Most golfers will score above the mean. No. Most golfers will either score. No, wait. More golfers will score above the mean than below the mean. Wait, what? Most scores will either be very high or very low. That's the only one that makes sense. This is a tough one right here. Hey, Madeline, good to see you here. We're about to finish off. I need to let me send out the class in 12 minutes email so people join into the stream, because I'll need to end the stream here in a moment. This one, they are doing a little bit of fun right here on us, because they're analyzing it differently than I would. Let me send out class in 12 minutes. People are already saying here in the chat on that one. There we go. Class in 12 minutes. Be early for bonus. Click here. Okay. We'll finish off this question, then we'll go to class here in a moment. Link works. Good to go. Sending announcement. Okay. Why would it be bimodal? Because none of these other answers make sense. Every golfer will have a different score. That's not true. That's just not how golf works. Every golfer will be above the mean. No, you can't, because the mean is the average, so every golfer can't be above the mean. More golfers will score above the mean than below the mean. It's theoretically possible. Don't like this question at all. If this top one is true, let me read it again. The player scores at the U.S. Open Golf Tour every year. Yeah, this one seems a little unfair. Good thing we're showing it, right? Because more golfers will score. This and then this has to be skewed. So if it is this one, it's going to be unimodal and skewed. So what they're saying is more golfers will score above the mean. So they're saying that is such a weird way of saying it. I agree with the bimodal thing. So they're saying it's skewed. What they're pointing to with that answer, some of the answers were just theoretically impossible. More golfers will score above the mean. So the mean, there's going to be a few golfers so they're saying it's left skew, because think about this. You know how we're doing mean and median right here? The median would be here, and more golfers are scoring above the mean. Does that make sense? So more golfers, this is the 50th percentile. So way more than 50% of golfers are scoring above the mean, because that's the 50th percentile. Does that make sense right there, Evan? It was a weird way of saying this will be left skewed. They could have just said they'll be left skewed or something, but that there's like only a few golfers who do like really well. Like there's like this general, like I had an okay game, and then some people have some really awesome games. And maybe this would be centered around like 72 or something like that, like a little bit above par. And then there's a right skew down here at like 60, where only like some really awesome games are down there. So they're saying it's more of a left skew distribution, which they could have used better words for that. Weights of females born in a particular hospital over a given year. This is probably going to be pretty unimodal and symmetric. Or is it going to be like babies are like, let's see what their answers are first. It's going to be like babies have very high weights or very low weights. Some babies would be much lighter than the rest. Very possible. Most weights would either be very high or very low, with few babies in the middle. No, you got like an average weight of baby. Every baby won't have a different weight. Most babies will have an average weight with about the same number of babies lighter than averager as heavier. Yeah, so I think they're going to go for unimodal symmetric right here. You get infinite attempts at these, so even if you get it wrong, you can redo them. The length of average hair on the heads of students in a large class. Now this one, think about this. This is a very what. So this answer right here is very, very what, Evan. So if you went into a classroom, I know where they're going with this one, and you looked at people's lengths of hair, how many inches long their hair is, this is a very what distribution. So this distribution, this one's a little bit more obvious. Not categorical, so length of hair. So you walk in, because maybe I'd go like, well, it's quantitative, but the distribution is probably going to be what? Unimodal, bimodal. I think this one's a little bit more obvious. Like this one's one of the most obvious ones, I'd say. Unimodal, bimodal. Bimodal, because you got people with like long hair and you have people with short hair. And it's probably going to be, it might be symmetric. That's the iffy one. Every student will have different length of hair. No. Men's and women's distributions have different modes. It's possible to have very long hair, but hair can't be negative. Correct. That's true. Most studies. You gotta love a typo. Most students will have hair that's shorter than the mean. No. So we should be good. The symmetric, really? That's just mean. It is very possible. I guess what they're getting at here for that last one, which is, I think, ridiculous, is they're getting at there's a hard stop to how short your hair can be, but it can be much longer. So they're talking about this over here because they're saying it's not perfectly symmetric because there's no upper bound to how long your hair can be. So it could be very right skew. There could be extreme outliers. I prefer they say that. It's probably going to look something like this. Like there's going to be a length of hair probably about here that most people don't have. You can obviously have your hair to this length, but usually people are going to go somewhere, and there might even be multimodal, like super short, medium length hair, and then longer hair towards shoulders. And we can even talk about more modes, but you're going to see some sort of areas where people have like shoulder length hair, or people have like hair right on their ears, or people have like buzz cuts. So that's what they're getting at. The skewness of this, they're talking about there is no upper bound, but there's a hard stop to like, you can't be left skew because there's no negative values to hair. So there we go. Good stuff right there. Pretty good question. Few parts of it just are a bit oddly asked. We always are very careful when we put questions on the test, but we'll be back here next time. Bye for now, everyone.